exercise 1.2 of set theory. Today I am going to keep that exercise in my live class in just a bit of seconds. I am going to share with you exercise. This is your exercise, exercise 1.2 of the chapter set which you studied in class 11. In question number 1, which of the following are the examples of the null set? Now, firstly, what is the meaning of the null set? I am going to explain you. I am going to share the whiteboard along with you. Sets. Exercise 1.2, class 11th. First one, the topic came here, null set. Null set is denoted by the symbol this or simply this. Null set is also known as empty set. That means the set having no elements. For example, if we say set of Indian Prime Minister before 1947. So there is no Prime Minister before 1947 of India. So it is a null set. Now I am going to solve the questions of this exercise one by one. Now this is the question number 1. In the following, we have to find which are the examples of the null set. Now see the first one. Set of odd natural numbers divisible by 2. So what are odd numbers? Odd numbers are the numbers which are not divided by 2. And here it is given that we have to find the odd natural numbers. So what are odd natural numbers? That is 1, 3, 5, 7, which are divided by 2. But all these are not divided by 2. So set 1, it is a empty set. That means we don't have any element, which is the odd natural number and it is divisible by 2. So this is an empty set. First one. Now second one. Set of even prime numbers. So the number should be even, that is 2, 4, 6 and 8. These are the even numbers. And even and prime, the number should be both even and prime. So only 2 is the even number and also a prime number. So we have a element in the set, that is 2. So it is not a null set. Now third one. X is a natural number in which x is less than 5. That means it is 1, 2, 3 and 4. And x is greater than 7. That means we have 8, 9, 10 and up to infinity. So say whether it is a null set or not. So it is given over here in between them, and that means we have to find a number which is both less than 5 and it is also the greater than 7. So we don't have any common number in between them. So we don't have any common number in between them. That means if we find the intersection of 1, 2, 3 and 4, intersection of 8, 9, 10, we don't have any common number. So it becomes a null set. We don't have any element like this. Now y is a point common to any parallel lines. Now if two lines are parallel, then there is no point which lies in the both line. So this is also a null set. So this question is completed. I am shifting to another one. So let's see the another question of exercise number 1.2. Now question number 2 we have to tell the finite and infinite sets. What are finite sets and what are infinite sets? Okay, I have got a problem. Just wait a little bit. I'll just download it and then again reopen it. Sorry, I have to go with that. Yes, I have got there. One point. Question number 2. It becomes absurd. You have to wait a little bit. Okay, we have to find the finite and infinite set. Now, what is finite set and what is infinite set? If number of elements can be counted, then it is the finite set. If number of elements cannot be counted, then it is infinite set. Now the first one, set of months of the year. So in the first, we can count them from January, February up to December. And we have 12 months. So first one is the finite set. Second one, 1, 2, 3, and it goes to infinity. So whenever it goes to infinity, that means we don't know how many numbers are there. So we cannot count them. We cannot count them. So it is non-finite, or we can say that infinite. Now, third one, it is limited up to 100. So we can count that they are 100 in number. So this is infinite set. Now, set of positive integers greater than 100. Positive integers greater than 100, that means 101, 102, and it goes to infinity. Lot of numbers are there which are greater than 100. So it cannot be counted because it goes to infinity. So it is also infinite. Now the last one, set of prime numbers which is less than 99. That means 2, 3, 5 and up to 99 prime numbers. So that means you can write 97. Okay. So now these are limited from 2 to 97. That means we can count them. So this is a finite set. Now question number 2 is completed of your exercise. Now question number 3. State whether each of the following set is finite or infinite. Now the set of lines which are parallel to x-axis. We know this is x-axis. Now we can draw unlimited number of lines which are parallel to x-axis on both the sides, and we cannot count them. So it is infinite. The set of letters in the English alphabets. Now in English alphabets, we have a set of letters from A to Z, and we can count them. They are in 26 in number. So it is a finite set. Set of numbers which are multiple of 5. Now, multiple of 5, 5, 10, 15, but it goes up to infinity. Unlimited numbers are there. So it is infinite. Now, next question we have. Set of animals living on the earth. Living on earth. So on the earth there are limited number of animals, and it's not easy to count them, but we can count them. So it is a finite set. It's, we can't say that we cannot count them. We can count them. Next, set of circles passing through origin. Now what is origin? We have x and y axis. Now this is origin. We can draw lot of circles from this point. Okay. So infinite number of circles can be drawn through origin. Hmm. Hmm. Now in the third question we have to tell the finite and infinite set. So all the questions I have done. In the first one we have set of lines which are parallel to x-axis, they are infinite. Set of letters in the English alphabet, they are A to Z, they are 26 in number. Set of numbers which are multiple of 5, that is 5, 10, 15. So we cannot count them, so it is infinite. Set of animals living on the earth, we can count them, so it is a finite set. Set of circles passing through origin, they are infinite in number. Okay. So now, next question we have question number 4. Whether they are equal or not. Now I am going to explain you when the sets are equal and when the sets are not equal to each other. Now we have to tell in this question whether they are the two sets, they are equal to each other or not. That means we have to find whether the sets are equal or not. Now set A is equal to given as A, B, C and D. In the B set we have D, C, B and A. So now you can see that the elements are same over here, B and B, C and C, D and D. So number of elements we see, they are equal to each other, 1, 2, 3 and 4, 1, 2, 3 and 4. So A and B are equal to each other. Now second one, set A has 4, 8, 12 and 16. Set B we have 8, 4, 16 and 18. Now here we can see that we have 4 and 8 and 16 also. But 12 and 18, these are different to each other. But number of elements of A and number of elements of B, they are equal, 1, 2, 3 and 4. And here also we have 1, 2, 3 and 4. So when number of elements are equal, then it is equivalent but not equal, because here the elements are different, 16 and 18. So we can't say that they are equal to each other. So second is not equal to each other. Now third one, A is equal to 2, 4, 6, 8 and 10. And the second set we have B is equal to is a positive set of integer less than or equal to 10. It is a positive set of even integers. Positive set of even integer less than 10. Now set of even integers less than or equal to 10. श्लोक इसको बंद करो, श्लोक इसे बंद करो. Now here you can count them, they are equal. Number of them are equal. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. So number of elements of A and number of elements of B, both in 5, they are equal. And all the elements are also equal to each other. So A and B are equal to each other. Now in the next question, next part we have A is equal to x such that x is multiple of 10. And B is equal to 10, 15, 20 up to 30. Now in the set, it means a multiple of 10. That means we have only 10, 20, 30, 40, dot, dot, dot. But here in the set B, we have 10, 15, 20, dot, 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 up to 30. Now here some extra elements are there. 15, which is not present in A. So A is not equal to B. Now next question of the exercise. Question number 5. First part. We have A is equal to 2 and 3 and B is equal to x such that x is solution of x square plus 5x plus 6 is equal to 0. Now element of A are given. Now we have to find the element of B. That means we have to factorize this. X square plus 5x plus 6. Now when we factorize, we get x square plus 2x plus 3x plus 6. Now we take common x plus 2 plus 3 x plus 6. So it becomes x plus 2 and x plus 3. So value of x becomes minus 2 and minus 3. So in the set A we have 2 and 3, and in the set B we have minus 2 and minus 3. Now the elements are not equal to each other, so A is not equal to B. Next question. Second part. A is x such that x is a letter in the word follow. B y such that y is a letter in word wolf. Now the set A becomes F, O, L, O we can't repeat F. From the word follow, we cannot repeat any letter again. Now B we have W, O, L, F. Now we have to observe we have 1, 2, 3 and 4. 1, 2, 3 and 4 both are equal and the letters are also equal. So set A is equal to set B. Now the question number 6 we have I'm shifting to next page. I have to bring that question on the screen so that you can understand it properly. God. Now I have to type again. Now question number 6. We have a set like this. A is equal to 2, 4, 8, 12. Set B is equal to 1, 2, 3 and 4. Set C is equal to 4, 8, 12, 14. D is equal to 3, 1, 4 and 2. E is equal to -1 and 1. F is equal to 0 and A. G is equal to 1 and -1. Now H is equal to 0 and 1. Now we have to find the pairs of the equal sets. Now we can see easily E and G, they are same, because in E we have -1 and 1, in G we have 1 and -1. So we have two elements in both and the elements are also same, so E is equal to G. Now this is 0A and 0, 1, so these are not equal to anything. Okay, now you can see D and B, they are also equal, because in B we have 1, 2, 3 and 4. In D we have 3, 1, 4 and 2. So order can't be matter too much. We have 4 terms, and 1, 3, 4, 2. So that means B is equal to D. Now 4, 8, 12, 14, 2, 4, 8, 12. So A and C, they can't be equal to each other. So only two pairs are equal to each other and nothing else. So we have got a lot of disturbance today, but now the exercise